Hi, and welcome to the Worldwide Center of Math's Problem of the Week. This week, the problem is let V and W be the subspace of R2 spanned by the vector 1, 1, and 1, 4, respectively. Find the vectors V belonging to V and W belonging to W so that V plus W is equal to 2, 3. So to begin, what we know is that little v belongs to the subspace of R2V spanned by the vector 1, 1. So what that means is that little v is equal to some constant. We can say t. Actually, let's call it s times 1, 1. And we can do a similar thing for w. We know that w is part of the subspace w of R2 that is spanned by the vector 1, 4. So w is then equal to some constant t times the vector 1, 4. What we can do now is write an equation using what we've described for v and w, and using that we know that v plus w should be equal to the vector 2, 3. So we know that v plus w is equal to 2, 3, so just substituting these in, we get s times 1, 1 plus t times 1, 4 is equal to 2, 3. And we can actually then write this in matrix form and then solve for what s and t are equal to. So what we can do is write this in matrix form as 1, 1, 1, 4 times st is equal to 2, 3. What we can do now is, in order to solve for st, what we would actually do is multiply both sides of the equation by the inverse of this matrix 1, 1, 1, 4. And what we get is that st would be equal to the inverse of the matrix 1, 1, 1, 4 times 2, 3, times the vector 2, 3. So now we must find the inverse of this matrix 1, 1, 1, 4. And for 2 by 2 matrix, that's pretty easy. For a matrix A, B, C, D, the inverse of that is actually equal to 1 over the determinant times the matrix D, negative B, negative C, A. You just switch the places of A and D and then put negative signs in front of the C and B. So we can do that there now with the matrix 1, 1, 1, 4. So what we get for the inverse is 1 over the determinant, which is 1 over 3. Obviously, what we do is we get 4 minus this 1 by taking the determinant and then switching the positions in the same way that we would do for this 2 by 2 matrix that we showed over here. We get 4, negative 1, 1 times the vector 2, 3. And what we end up with is 5, negative 1 times 1/3. Really what we can do is just take this 1/3 out as a constant, just keep it as a constant, multiplying times the vector that we end up with. So now we can solve for actually what s and t are equal to. Obviously s is equal to negative 5 over 3, and s is equal to 5 over 3, and t is equal to negative 1 over 3. So now that we know what s and t are, we can solve for what the vector v and w is equal to just by substituting those values in. And substituting in, what we get is v is equal to 5 over 3, 5 over 3, and w is equal to 1/3, 4/3. T here actually should just be 1/3. There shouldn't be a negative sign. If you do out the matrix multiplication here, you'll see that there actually shouldn't be a negative sign on that second term in the vector 5, 1. So then we get w is equal to 1/3 and 4/3. And what you can do to check this is then plug these into the equation, and what you'll see is that it comes out to be that v plus w is in fact equal to 2, 3. So that's all we have for you today for this week's Problem of the Week. I hope you enjoyed watching it. Please check out some more of our videos on YouTube, check us out on Facebook, and follow us on Twitter. Thank you.